Chemistry is the study of matter and the changes it undergoes. In order to have a strong understanding of matter, it is important to understand the atom, its parts, and how they combine to form matter. An atom is defined as the smallest particle of an element that retains its physical properties. A good timeline of the atom and how its model has evolved is below. For Democritus and Dalton, they weren't working on a clear idea of what an atom looked like, more a theory of atomic properties. Then Thomson came up with one of the first models of an atom, followed by Rutherford and Bohr, whose model is still used today as an easy model for students to recreate, followed by the modern quantum model, which was created during and updated after the 1930s. Sir William Crookes, an English physicist, discovered the electron while working in a cathode ray lab. The cathode ray, think of an early neon sign, worked by streaming electricity from the cathode or negative side to the anode or positive side. Every time he filled it with gas and streamed particles this particular way, the gas would light up and react, but it would not react going from positive to negative. Crookes then changed the cathode and tested again, same results. Then he also changed the gas and still had the same results. Therefore, he concluded that negatively charged particles were found in all forms of matter and called them electrons. Robert Millikan, an American physicist, conducted what is famously known as the oil drop experiment to determine the charge and mass of an electron. He discovered that the charge of an electron is -1, and the mass of an electron is 9.1 times 10 to the -28th grams, or 1/1840th mass of a hydrogen atom. An important reference point is that the hydrogen atom is the smallest atom on the periodic table. While Crookes and Millikan were busy discovering and experimenting on electrons, Rutherford was busy designing the gold foil experiment that proved the existence of the nucleus. He aimed an alpha particle generator at the gold foil, in which he shot alpha particles. He expected them to be evenly deflected, but found the majority passed through undeflected, but some were deflected and at some almost 180-degree angles. This proved to him that instead of the model that had the positive particles evenly throughout the atom, there were large areas of low-mass electrons surrounded by a very dense positive center. The structure of the atom is the same for every element. The nucleus is the center filled with protons, positively charged particles, and neutrons, neutrally charged particles, with electrons, negatively charged particles, floating around the nucleus. Electrons may never, ever, ever enter the nucleus. The atom is made up of three things. First, the proton, which is found in the nucleus and is positively charged. The proton is abbreviated P+, with a relative electrical charge of 1+, a relative mass of 1, and an actual mass of 1.673 times 10 to the -24th grams. The electron is in the space surrounding the nucleus and is negatively charged. The electron is abbreviated E negative, with a relative electrical charge of 1 negative, a relative mass of 1 over 1,840, and an actual mass of 9.11 times 10 to the -28th grams. Finally, the neutron is found in the nucleus and is neutrally charged. The neutron is abbreviated N to the 0, with a relative electrical charge of 0, a relative mass of 1, and an actual mass of 1.673 times 10 to the -24th grams. When looking at the periodic table, it is important to note that the atomic number is the number of protons, which equals the number of electrons. These two numbers will always be equal and are different for each element. Additionally, you will find the chemical symbol, also called the atomic or element symbol, which is a specific 1 to 2 letter chemical abbreviation in which proper capitalization is so very important. Capital C, capital O is carbon monoxide, but capital C, little o is cobalt. The chemical or element name is also provided, as well as the average atomic mass, which is always measured in grams per mole.